So looking at number 3, there's the table and the picture. But I want to go one step further with number 3 and actually solve it and get an answer and see if it matches with our picture. We won't always be able to do that. Like number 4, we don't know how to solve. 2 and 1 we sort of could, but 3 is probably the easiest one to solve, so that's why I want to do it. So the method we're going to learn tomorrow, so we're kind of ahead of ourselves, is called separation of variables. So anybody want to try to describe what our first step will be on this problem? Just take a wild guess. What should we do first? We should probably separate the variables. Very nice. So let's get all the x stuff on one side and all the y stuff on one side. Now this is a little bit tricky, and this is where calculus teachers debate how do we explain this, because dy dx, that's one idea, right? That's slope. Dy dx is together. And so what we're about to do feels a little bit weird, or it should feel a little weird. We're going to separate those. So I'm going to multiply dx to the other side and multiply y to the left side. And so I've separated the variables. I've got all the x's on one side, all the y's on the other side. Then to undo so somebody has taken a derivative, that's the d stuff. To undo that, let's integrate both sides. I'm going to leave the negative out front, although it doesn't really matter. So what's the integral of y dy? You know what? Let's do the other side first, because that's an easier side, I think, because we're used to working with x's. What's the antiderivative of x? Yeah, x squared over 2, or 1/2 x squared. Negative 1/2 x squared. Plus c. You can put the plus c on either side. You can put it on both, but you don't really need to put it on both. So the integral of x is x squared over 2. The integral of y dy. So we're integrating y, but with respect to y. So any ideas on what that will be? It's sort of the same thing. So 1/2 y squared. And again, you can put the plus c on either side or both sides, but most people just out of habit put it with the x. Let's see. That's sort of done, but to make it look more familiar, I'm going to move this x stuff over. So I've got 1/2 x squared plus 1/2 y squared equals c. And then I wouldn't have to do this, but to make it really look like a circle, I'm going to multiply through by 2. And remember, c is anything at this point, so it doesn't really matter if I do c or 2c. That's still any constant. If you want to put 2c, it's not wrong. And then hopefully you recognize, hey, wait a minute, that's a circle. And so that matches with the picture that we drew. So that's why I wanted to do this separation of variables problem, because it's one that's not too hard to do, and you get an answer that you recognize and you know what that shape looks like. So number 3 is a good one to sort of see everything that we can do with this slope field table, slope field picture, but also actually work the problem, get an equation that sure enough matches our slope field. Why don't you take a couple minutes and let's try, I want to do one that has x and y in it, but that we haven't done yet. Let's try number 3 and number 6. Try 3 and 6. Again, if you're working on others, it doesn't really matter. It's whatever we don't get done in class, we'll do at home. So this is the same thing as the last page, except it doesn't give you a table to fill out. So you kind of have to do the table part in your head and then put it on the picture. So maybe we should do a few of these together. So x plus y. So if I'm at -3, 2, so x is -3 and y is 2, what's my slope going to be? -1. So I'll do a slope of -1. So the end result is the same as the last page. It's just you don't have a table to rely on. You got to do that table step sort of in your head. All right, what about -2, 2? -2, 2. So this definitely takes some thought in your head to identify the point, -2, 2, and then plug it in. And what's dy dx at -2, 2? 0. And so then I do a little slope of 0. And then at -1, 2, -1, 2, -1 plus 2 is 1. 0, 2, I have a slope of 2. These are going to get really steep over here on the top right. 1, 2 would be a slope of 3. 2, 2 would be a slope of 4. 3, 2 would be a slope of 5. So, you know what? Don't worry about 6 yet. Just finish 3. So there's the picture for number 3. Again, just at every single point, plug them in, get the slope, sketch the slope. Let's try number 6. Sometimes there's some easy points to pick off, like if x is 0, then the slope is undefined. But undefined doesn't mean there's not a slope. What does it mean the slope piece looks like? Maybe phrase it that way. What's an undefined slope look like? Vertical. So whenever x is 0, we have a vertical slope piece. If y is 0, then the slope is 0. So that's some. After that, we just kind of have to go point by point. Should be -2/3. And that one should be -2/3 as well. Or that would be, yeah, the top right would be -2/3. this one would be positive. My picture's still correct. I just had the wrong number listed there. All right, let's jump to number 17 on the very back. Work this one together, and then we'll be done, and your assignment will be everything that's left. So consider the differential equation given by, and by the way, by the look of this, I'm guessing this is an old AP test question, and you hope to get one of these. Like, these are usually ones that are okay. On the axis provided, sketch a slope field. Okay, xy times 2. So if x is 0 or y is 0, then it's equal to 0. So that knocks off some easy ones. After that, it's, well, not as easy. Maybe it'd be best to start in the first quadrant where everything's positive. That way you're not having to worry about negatives. At 1, 1 times 1 over 2 would be 1/2. 2, 1 would end up being a slope of 1. 2, 2 would end up being a slope of 2. 3, 2 would be a slope of 3. Again, if you need to like write some out, so the 0.31, the slope would be 3/2 or 1.5. There's our picture. All right, part B, part we wanted to get to here. Let f be the function that satisfies the given differential equation. Write an equation for the tangent line to the curve y equals f of x through the point 1, 1. Okay, an equation of the tangent line. So for a tangent line, I need slope and I need a point. Well, it gave me the point, 1, 1. How can I find the slope at 1, 1? I can just plug it in. It told me what the slope is. This is a little bit weird or backwards from what we usually have to do. Usually we have to take a derivative to find the slope, but here they gave me the derivative. So if I plug in 1, 1, I get the slope is 1/2. So now I can write my write an equation for the tangent line through the point 1, 1. Okay, so y minus 1 equals 1/2 x minus 1. So that was the first thing it asked. Then it says use your tangent line to estimate the value of f of 1.2. So at 1, 1, here's my tangent line. Well, the tangent line should give me a reasonable guess for what the function at 1.2 is. 1.2 is the x value. So I'm going to take my tangent line. First I'll solve it for y. So just move the 1 over. And then I'll substitute in 1.2. So 1/2 1.2 minus 1 plus 1. And that will give me an approximation, a tangent line approximation. Let's see, 1.2 minus 1 is 0.2. Actually, that's a safe stop, but I kind of want to get a real answer here. 1.2 minus 1 is 0.2. Half of that's 0.1. 0.1 plus 1 is 1.1. Part C. Find the particular solution. So that means actually solve this thing. So that's separation of variables. So dy over y equals 1/2 x dx. Okay, we're going to run out of time, but that means natural log of y equals x squared over 4 plus c. And I guess we'll pick that up on tomorrow, but I can then plug in 1, 1 to figure out what c is. Alright, so your job is to finish this worksheet packet. We've done a big chunk of it, and we'll go over the rest of it on